Welcome once again. In the last video, I explained question number 1 and I solved it, question number 1. Now I'm going to solve question number 2 from exercise number 9.2. Let's see the question. What is the question? Look at the book, all of you. If E, F, Z, H respectively are respectively the midpoints of sides of parallelogram A, B, C, D, so that area of A, F, Z, H is equal to half of area A, B, C, D. So before that, I would like to draw the figure for this particular question. So A, B, C, D, E, F, Z, H respectively are the midpoints of parallelogram A, B, C, D. So first let me draw one parallelogram A, B, C, D. A, B, C, D is one parallelogram. A, B, C, D is a parallelogram. A, B, C, D. A, B, C, D is a parallelogram in which the midpoints are given. E, F, Z, H are the midpoints of the sides. E, F, Z, H are the midpoints. E, F, Z, H. These are the midpoints of the sides of a parallelogram ABCD. So ABCD is a parallelogram. E, F, Z, H are the midpoints of the sides. So what to prove? Area of EFZH. Area of EFZH. So I have to join all the 4 points for getting EFZH. EFZH. Join all the 4 midpoints so that I will get EFZH. So area of EFZH is equal to half of area ABCD. That we are supposed to prove. So for that, first thing is just locate the midpoints, join all the midpoints, you will get EFZH. Next, here for proving this one construction is there. So for that construction will be join HF. Join HF. Join HF. So now you see, it is a parallelogram. First part we will write what are the given things. So given, first thing is given. What is given? We will write. Given, this is question number 2. Given, what is given? First thing is ABCD is a parallelogram. ABCD is a parallelogram. Parallelogram. So symbolically we can write parallelogram like this. ABCD is a parallelogram. Next, EFZH are the midpoints. EFZH are the respectively the midpoints of all the sides. E, F, Z, H are the EFZH are the midpoints. EFZH are the midpoints. Are the midpoints of AB, BC, CD, DA. AB, BC, CD, DA respectively. So these are the given things. To prove, what to prove? To prove area EFZH is equal to half of area ABCD. To prove area EFZH is equal to half area ABCD. Area EFZH is equal to half area ABCD. So one construction is there. Write that construction. Construction is what? Construction is HF is joined. HF is joined. Now let's come to the proof part. That's very interesting proof. It's so simple one. Just listen properly to each and every point. This very simple one. Listen properly to each and every point. How I am going to prove this. First thing is identifying the parallel lines. That is very important. Same base is very important because this particular exercise is already based on figures lying on same base and between same parallel. That's why it is very important and essential part to identify the parallel lines and the base. That is very important. Now have a look at this properly. So proof part, I am going to prove it. So first is, what is that? Proof. First thing is, you see Here you can see all are the midpoints. Midpoints or not. Now, if we see AD line is parallel to BC line because opposite sides of parallelogram are parallel. So first thing I will write AD is parallel to BC. AD is parallel to BC because opposite sides of parallelogram. And AD is equal to BC. Both are parallel as well as AD is parallel to BC and AD is equal to BC. Why? Write the reason why. Opposite sides of parallelogram. Opposite sides of parallelogram. Opposite sides of parallelogram. Next, I will take half on both sides. Why I am taking half? Because look at the construction line. The construction line is divided the whole ABCD triangle into two parts. Divided in the middle section. You can see here. These are the midpoints, H and F. That's why I am going to take half on both sides so that I can take half of this particular side, AD side. That's why next step is take half on both sides. Multiplying half on both sides. Half of BC. So this implies half of AD. Half of AD. Look at AD here. AD. If I need to write half of AD, this AD is the complete side. For that, since H is the midpoint, in place of half of AD, I can write HD. I can write HD. So in this one, I can write HD is equal to half of BC. Look at BC here. In place of half of BC, I can write CF. CF. Why I have written like this? Because H and F are the midpoints. H and F are the midpoints. Midpoints. That's why I can write midpoints. That's why I can write half of this as in this part. HD and CF. Next, look. HD is equal to CF. Now this complete line AD, this complete AD line is parallel to BC line. AD is parallel to BC line. Now say this particular complete one long this length, the line is parallel to this line. Now if I cut the line at any part, this two line will also be parallel. If I say this is very, the line is too lengthy. The length, look at the length of the line, it is very long. Now these two lines are parallel. If you cut the two lines, then the remaining two part will also be parallel. Similarly, this long AD line is parallel to BC line. Now look at HD will also be parallel to CF. I can write HD is parallel to CF. So HD is equal to CF. I can write from here AD parallel to BC. I can write and HD parallel CF. I can write. Okay. So now look, HD is equal to CF and HD is parallel to CF. HD and CF both are opposite sides. Opposite sides are, first time I got equal and second time I got parallel. If opposite sides of a quadrilateral are parallel and equal, then it will be known as, or it will be called parallelogram. So I can write HDCF is a parallelogram. Therefore I can write HDCF is a parallelogram. So this part till here it is okay. HDCF is parallelogram. HDF is parallel. CF is parallel. Now look, have a look at the figure. Look at here. HDCF is a parallelogram, and look at here. ZHF or HFZ here. Look at ZHF. This one is a triangle. Triangle or not? The part that I have shaded. Okay, this one, the part that, this one, HCF is a triangle and HDCF is a parallelogram. Look at that parallelogram and triangle. The parallelogram and triangle lies on the same base, HF. HF is the same base, common base for both the triangle and the parallelogram. And between same parallel, DC and HF are parallel because it is a parallelogram. That means the parallelogram HDCF and the triangle HCF lies on the same base and between same parallel. So if a parallelogram, this time it is a parallelogram and a triangle. If a triangle and a parallelogram lies on same base and between same parallels, then the area of the triangle will be half of the area of parallelogram. So you have to remind this. If a triangle and a parallelogram lies on same base and between same parallels, then the area of the triangle will be half of the area of parallelogram. So that's what I'm going to use now here. So what should I write? I will write like this. Let's see here. What can I write? I can write now HCCF is a parallelogram. Next part will be, I will write since HDCF and HDCF parallelogram and triangle ZHF lies on same base. What is that base? HF is the base. Lies on same base. HF lies on same base. HF and between same parallels What are those parallels? One is CD, another one is FX, or DC and HF. DC and HF lies between same parallel and on the same base. Therefore, what can I write? Therefore, area of the triangle. What is the triangle? Area of triangle ZHF. Area of ZHF is equal to half of area of the parallelogram. Parallelogram means ABCD. So the parallelogram ABCD. So give this equation number 1. Why I have written area of the triangle is half of the area of parallelogram? Because why? Because the reason is, if a parallelogram and a triangle lies on same base and between same parallel, then the area of the triangle is half of the area of the parallelogram. In this case, this is the same base and these are the two parallels where the triangles and the parallelogram lies. That's why I have written like this. Now look, the upper part is open. Similarly, you just have a look at the down part. Down part means I'm talking about HEF. Look at the down part. HEF is a triangle. And this one is a parallelogram. So this triangle, similarly, I don't need to prove that because the process will be same only. So I can write similarly. So this particular triangle, that is HFE and HABF, is a parallelogram. Both lies on the same base and between same parallel. So I can write similarly. I will write on this side. So on this side I will write similarly. What I will write? Similarly, I will write area HEF is equal to half area the parallelogram. What is the parallelogram? HABF. So that means this, how I got this one? The way I got this, similarly I got this one. So area HEF, this is a triangle, and area HABF will be half. So now make this equation number 2. Equation number 1 and equation number 2. Now look at equation number 1. In equation number 1, triangle ZHF is there. In equation number 2, a triangle HEF is there. Now the proof is HEFZ. For getting HCFZ, I need to combine these two, both the triangles. I need to add it. If I add both the triangles, then I will get that particular parallel quadrilateral. So for that, getting that one, I need to add 1 and 2. So what I will do now, I will write on this side. Now, what I will write? Again I'm telling, for getting this whole EFZH, I need to add both the triangle. One triangle is in equation number 1, another triangle is in equation number 2. That's why I will add 1 and 2. Now 1 plus 2. Now 1 plus 2 gives 1 plus 2. While adding an equation, we have to add left hand side with left hand side and right hand side with right hand side. So for that one, what I will do, area HEF area HEF plus area ZHF, area ZHF is equal to, so this part along with this part, left with left, right with right, separated by the equal sign. So area HEF and ZHF is equal to half, what is that? HABF, half area HABF plus half HABF plus half ABCD, half ABCD. Okay, now look, if I add both the triangle, if I add both, combine both the triangle, that means combining both the triangle, I will get EFGH. So in place of this two, if I add it, I can write area EFGH is equal to, this side you just take half common, half you just take common, half area HABF plus HABF plus ABCD plus not ABCD plus ABHF ABFH. So mistakenly I have written ABCD, but it is not ABCD. ABFH, and one is this one HABF, and another one is the upper one, this one HFCD. So plus area HFCD. Okay, now combine these two parallelogram also. Look at this, the upper one parallelogram, upper one plus this one. If I combine both the parallelogram, I will get completely ABCD. So that is implies area EFGH is equal to half area ABCD. That is what we are supposed to prove. So I think in equation number 1, if I have written ABCD here, that is not ABCD, that should be HFCD. I think by mistakenly I have written like that, if I have written, because I after that I forgot what I have written. So now this is how we have to prove this one. So this is how we have to prove the other question also. So I will attach some solve questions on the group. You just go through that. If you have any doubts, you just ask me. Okay, thank you.